Okay, so in some of the previous videos, I've been showing you how to get your students started coding, and I've showed you how to make a motion diagram in those simulations, and also to introduce a second particle. Sometimes you're in a position where you're not really looking for students to get um, started with the coding by themselves, and you want to introduce some code to them in some sort of situation that helps them to give some relevance. And this isn't the best example, maybe, but it's an example that I used early on. My students will have worked through a problem on a whiteboard about how high above a building a ball will get if it's tossed at 25 meters per second. Our goal in the class was to figure out, does it get as high as the building outside? And if it does, then how high above? And if it doesn't, how far below? So students will have worked through that problem. And then they open up this Desmos simulation that says, ask them to compare the equation that they wrote down to the equation that they had, and it should be the same if they did it right. And then to press play in the simulation and to see how high the ball in their simulation gets, and you can sort of drag it around, and so they can verify their answer without having me have to do it. One of the things in my class is that students will have been asked to come up with other questions that they could ask about the situation. Sometimes students will say things like, well, how much total time does it spend in the air? Or if it comes back down and hits the top of the building, how fast does it hit the building? And what I ask students to do is to explore the simulation to get those same things. And so if students wanted to, for example, figure out how much total time it spends in the air, they could run the simulation and find out that it would hit the ground at about 5 seconds later, and a little after 5 seconds. And that's because it took 5 seconds to get back to the original position, but it was thrown from 1 meter above the ground. So there's a fraction of time to cover that last meter. But another thing that we practice in my class is these sort of what-if questions. For example, what if the ball was thrown with twice as much speed? How much higher would it go? Or how would you need to change the equation so that it represents a ball thrown with twice the speed? And so students would be asked to go back up to this equation and to change the 25 to 50, and then to explore what effect that had on the simulation. In my particular class, the way we did this is having a clicker question where students debated what effect that had. Would it go twice as high? Would it go more than twice as high? Would it go less than twice as high? Would it get to the same height? And we can see that it actually gets a lot higher when you throw it twice as fast. And in fact, we can see before it got up to like 30 something, and in this case, it's getting up to like 120 something. And so it looks like it got 4 times as high when we threw it twice as fast. And so this is some of the ways that I get my students sort of using Desmos in a way that doesn't require them to do a lot of the coding, but gets them thinking about the equations, thinking about the meaning of the equations, and having to make some minor adjustments in order to investigate the situation.